All right, let's look at different methods of drawing um ellipse. So I'll be using this technical drawing manual with soft past questions curriculum 1 by Ike Ajayi. Now I'll be using that to look at the eccentricity method, the concentric method, um, the ellipse method, focal point method, and charm mesh method. So I'm going to be starting with electricity, charm mesh, then go through over these ones. And also after each video, I'm going to be putting a practical question. So now let's look at this. Now it says draw an ellipse when the distance of focus from the directrix is equal to 40 millimeter and eccentricity is, now the eccentricity is 2 over 3. We're using 2 over 3. So now given eccentricity AB and focus distance from directrix, so let's draw the ellipse. So the first step is draw the axis AA. All right, this is called directrix. This line DD is the directrix. Right, from this point towards this side is our axis. Now put the focal point. Now the focal point is 40 millimeter away from the directrix. So measure your 40 millimeter. Now I'll be drawing it with 2D board and also without 2D board, only our sketch pad. All right, so now this is my focal point F1. Next is to now use our eccentricity to get our vertex point. Now, given that 2 over 3, so we'll go add this 2 over 3. 2 plus 3, which is 5. So we divide from point A to F to 5 places, 5 equal places. From point A to F, we'll divide it into 5 equal places. So, and if from here to here is 40, from A to F1 is 40. So divide by 5 is going to be, 40 divided by 5 is going to be giving us 0.8. So I'll divide this from A to F to I'll measure 0.8. This 1. The next is 16. After 16, we have 24. After 2.4, we have 32. After 32, then we have 40. We've divided that into 5 equal. So the next to do now is from A, which is new, we use the eccentricity of 2 over 3. Now, the numerator will be the distance from F to vertex, while the denominator will be the distance from A to the vertex. So now, let's count 3 towards this side. 1, 2, 3, which is here. This is our V1, which is our vertex. That is 3 points towards the directrix and 2 points towards the focal point. So with this now, the next to do is draw a vertical line across this vertex point. You can see my placing my set square on my T square. Good. Then now we'll take our compass, put it at F. I'll take the distance from V. Okay, now with this radius, I'm going to put it at V and mark. Now that point that I mark, I will label it as point B. VB is equal to what? V1 F1. Now V1 is question. So now what next now is to draw a line from point A through B outward. Okay, from point A to point B. Point A to point B, then outward. Good. So now what next is to take 45 degrees set square, draw a line from focal point f1 at 45 degree. So I'll finish that with this. Good. So now from when this line from focal point is touching the line from point B, we're going to drop it down. So we call this point V2, vertex point 2. This vertex point 1. So now what we'll now do next is to, from vertex point 1 to vertex point 2, we'll divide to different numbers. It might be equal, it might be different dimension. Like now from V to 1, like what is my dimension? It's 8.9. So I can use 1 and use 2.5, and use 1 again, 1, randomly 6, 7, and so, okay, and like this. Okay, I'm going to be making from here to here to be 1, so that it will be of the same dimension with the first part there. You can make it equal, you can make it of any part. Okay, okay. So all you now do now is from all those points, you put a vertical line. Draw a vertical line as parallel to, okay, okay, this is my next. So now where this parallel lines cut this line A through B, we would start labeling it. This point 1, point 2, 3, 4, 5, 6, 7. That's 1, 2, 3, 4, 5, 6, 7. Okay. So what we're now going to do next is to take our compass, put it at point 1 to 1. Put it at point 1 to 1. Good. Then come to focal point. Mark 1 up. Mark here. Then put it at point 2, 2 to 2. Okay. Come to focal point. Mark, mark. Put it at 3 to 3. Put it at focal point. Mark, mark. Put it at 4. Okay. Come to focal point. Mark, mark. Put it at 5. Extend to 5. Put it at focal point. Mark, mark. Put it at 6. Extend to 6. Put at the focal point. Mark. Mark. Put at 7. Extend to 7. Put at F1. Mark. Mark. Yeah, so those are the point for our ellipse. So we'll get our French curve now. Now do is to use our French curve to join all the points together. Okay, I think I found the best part from here to here. Okay, even if it is the first two, take it first. Okay, you see this part that I use for this part, I'm going to bring it down here. Okay, I'm going to bring it down to also do this part. Let me take it to this part also. See what I can achieve here. This one, two, okay, it goes like this. And turn it to the other side like this. This part. Let me see what I can obtain here. Okay, okay, no, it won't go like that. Okay, I think it would go like this. Perfect. This two is go. So it's good to go. Okay, so I'm bringing it to the other side. This part. Okay, seems something like this will be better. Good. So just turn it to the other side. Good. So let's see this part. Okay, this part also goes well from here like this to this part. Okay, okay, so meaning we take it down like this, and here we go. Beautiful. Now here is our eclipse using eccentricity method. All right, so now the next is for me to use sketchpad and other drawing equipment. If you're having only sketchpad, you can also use your sketchpad alone without your T-square to draw your ellipse. So here we go. Now using eccentricity method, with just our compass and pencil and protractor, ruler, and set squares. So we're going to draw the eccentricity method for construction of ellipse. All right. So what we do is now at least put your protractor to see that your ruler is well placed. Okay, as it is like this, it looks well placed like this. All right. Okay, it looks well placed, and whichever way you place it will keep being on track. So now draw your horizontal line, then your axis. Now you see this point here, 0, 90. Set it on my straight line. Yeah, my vertical line will be 90 degrees to the horizontal line. All right, so I can put my ruler like this and draw. Okay, good. I label these are my directrix, and here to here as my as this. The question says, draw an ellipse when the distance of focus from the directrix is equal to 40 millimeter and eccentricity is 2 over 3. I said we are not using 3 over 5 because, okay, we can even use 3 over 5 at this point now. If we want to use 3 over 5, we can use 3 over 5, we'll still arrive at the same answer. So let's use 3 over 5. Let's look at what the textbook, the value that the textbook gave, but that was not the value depicted in the drawing here. You can see from here 1, 2, 3, 4, 5. They use 5, so which is meant to be 8 if they are to use this ratio. So let's use ratio 8 now. 3 over 5. That's 3 over 5, which is going to be 8 when you add it together. So that will be 8. So that means I'm taking my focal point 40, then I'm dividing into 8. That means I'll be using 5. 1, 2, 3, 4. That is 40 into 8 places. 5, 6, 7, 8. That's 1, 2, 3, 4, 5, 6, 7, 8. So the denominator is to the directrix, while the numerator is to the focal point. So F1, 1, 2, 3, 4, 5, 6, V1, vertex point 2, 1, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 5 towards to the directrix. And okay, now what next to do to draw a vertical line? Remember, we used to draw a vertical line. I put the 0 line on the straight line on the directrix. Also, make sure that this straight line also is also on the line here, and I put my ruler beneath. So and I remove this. So I'm not going to put this part now to draw line. I'm supposed to extend this line downward. So you can still put it again. 0 on this line, 990 underneath. Good. So now what next is to take the radius of F to V. Mark maybe here as point B. So now what we're now going to do next is to take a line from point B. As you can see, BV is equal to V1 F1. So from here through here, draw a straight line. Okay. Also from focal point, use your 45-degree set square to draw straight line. So at this point, I'm going to check my okay. So I'm going to put this here like this and then draw. Okay. So then from that point also, I will drop it down from here. This is my V2, that vertex point, which is gotten through 45-degree to this side from the focal point. What we are now going to do is, so as I've said, I'm going to divide this part into several halves. So I'm going to be using one. I'm going to be using the copper 2, 3, 4. Now, but from here, I want to have also 1. I'm using 0.1 from this side to this side. Then also from here, I use 0.1. Because I mean, you're my call, French call, to make it easier for me. Okay. what we're not going to do is to draw parallel lines just like this one we've done on V1 to all these points. This is 1, 2, 3, 4, 5, 6. So let me set. Now this line, this division between V1 and V2, I said it can be random. It's not a must to be equal. When these parallel lines are touching this line AB, we label it 1, 2, 3, 4, 5, 6. What next is to take our compass, then we measure from 1 to this point here. Good. So we put it on F. We will mark 1, 1. Put it on 2. Extend to 2. So we put it on focal point and we mark. Okay. Point, 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 point. Okay. Put it on 3. Okay. This is 2. Put it on F1. Mark. Mark. Put it on 4. Alright. What next is to join these curves together. Okay. Beautiful. And that's all. Here's our ellipse using eccentricity method.